Okay, today we are going to write about the array list. Last time we implemented a raw vec. Today we're going to implement essentially a vec, not implement it. I'm sorry. We're writing about it. We're writing about implementing it. We're writing about doing something instead of doing something. Because that's what happens here on this stream. No, I'm just kidding. That's what happens, I guess, half the time on this stream. Apparently writing is good, and apparently people appreciate the written word here and there, and we'll see if that's true long term. So far I don't know how much people appreciate the written word. Granted, I don't spend a lot of time trying to get the word out there, and the only actual social media I do is Zitter, besides YouTube, obviously, if you count that. But and yeah, basically it sucks on there for promoting any sort of content. It's really not good at it. You just get penalized for any sort of link. I've tried links in the second message. I've tried all of the tricks that they say to do, and no matter what, my bad takes get a lot of attention, and my content gets very little. So maybe that's just a statement on my content and not on the X algorithm, but it's kind of nice just to blame an algorithm instead of myself, right? So that's probably what I'll continue doing. All right. So with that amazing intro, let's see about writing about the array list here. Okay, so Rust DSA array list, implementing a vec array list, DynArray, same thing. Okay, very exciting. In most modern programming languages, there is a sequential data structure where with a dynamic length and arbitrary data. Okay. Data. In a typed language, that data typically has to be of a single type. And in a dynamic language, okay, in a typed language, that data typically has to be of a single type. Okay, maybe we just say strongly typed language. What about Python? So Python is strongly typed, but can you have a Python, what do they call them? Lists, I think. Python list single type. No, it's just anything you want. Hey, Felix, what's up? 1 second, message check. Okay, so I guess Python, you can have any type in a list. So maybe I'll just say statically typed. Sure. In a statically typed language, that data typically has to be of a single type. Okay. In Rust, this data structure is called vec. In Java, it's called an array list. In Java, it's called an array list. Do I have to, should I do the asterisk? And then people are going to be so confused. Like, why did you put an asterisk in JavaScript? I think I have to do that. It's called an array. because JS. You think the asterisk should be at the Java? Oh, I don't know. I don't know. I usually do it at the script. I just hate seeing this. Ooh, I typed it. Oh, it's rough. It's called an array because JS doesn't care. Good enough. It's just a joke anyway. In Java, it's called an ArrayList. In JavaScript, it's called an array because JS doesn't care. Yeah, very fair. That's good enough. I think 3 different languages is good enough. It is called... It is with apostrophe, right? Yeah, it is. It is. It's called vec. In Java, it's called an ArrayList. In JavaScript, it's called an array. But I don't know. I'm not a... I would really hate to look up docs right now. But... yeah, they call it array because you have a capital A array .of. I'm not going to put this in the code syntax because it's not a real programming language, right? Because they both have ArrayList. Okay, in Java and C#, it's called an ArrayList. Cool. Thanks, John. In JavaScript, it's called an array because JS doesn't care. And we'll just leave it at that. And arbitrary data. Okay, very cool. Okay, this... Okay. We'll just call it... No, let's see. Since vector can mean different things in different languages, we'll continue. Maybe I'll say I will use the term ArrayList in this article. Okay. I think that's good. Yeah. Amit got mad at this last time. He gets mad that I want to call it an array list because this just he thinks of a list being a linked list because he's from C++ world. But you know, that's okay. Making Amit mad is just part of my life. Statically typed language. Yeah. I will use the term ArrayList in this article. I think this is fine. John, you almost undermined my extremely good reputation. We'll just keep it in Java. I know Java at least, you know, speaking from some sort of experience. Though I am kind of wondering, like, what is just the list type in Java? Hey, Alice. How's it going? I know. Let's see. List is just an interface. That makes sense. An array list is what I'm thinking of. Yeah. Okay. I mean, it's been a while since I wrote Java. Like, for real. List is such a bad interface. I'm so shocked. I'm so shocked. This is my shocked face. There's if I was like other people, right? That would be my what do they call it? Thumbnail for the video. But it wasn't dramatic enough because, well, I don't make very dramatic faces. Since vector can mean different things, I will use the term ArrayList in this article. Okay. What do I want to talk about in this article? Let's write out a couple notes so that I actually talk about something. Something like, let's see. Okay, yeah. Based on raw vec, sure, contiguous memory buffer allocation. What else? Oh, right. The whole time complexity thing, because that's important. Time complexity. We won't go into it too deep because I actually just want to write a whole article on queues and stacks based on a linked list and probably doubly linked list and an array list, and then talk about the time complexity there. But we'll just go over general time complexity for get, fetch, delete. I think that's good. Oh yeah, get, fetch, delete. What am I doing? Get, add, delete. How about that? Tams from 987. Thanks for the follow. Welcome. Glad you're here. Okay, time complexity for get, add, delete. We want to talk about that. Is there really anything else to talk about for an array list? Is there anything special about it in Rust? I mean, just in the implementation, of course, we're going to have to use unsafe in order to read pointers and that whole thing. Yeah, hey, what's going on? Let's see. So it's going to require the use of unsafe because we're going to read those pointers from memory. We're going to deal with those raw pointers. We have to read them into our type. Yeah. Okay. Maybe a little bit about the implementation using unsafe. Is there anything else interesting about the implementation to like talk about? I mean, I haven't done the implementation yet, but I mean, I have a basic idea of what I'm going to do, right? What do we have on an array list? We have push and we have pop. We are going to do a get, like a get by index, which, right. So we'll do a get by index, probably just go ahead and, you know, implement the index trait. Do it a little idiomatically. Using unsafe, maybe index trait. I do feel like I don't know how I want to do iterators yet because I haven't actually done any iterators for these types, but I feel like maybe that will just be a whole article. Is I'll go back and create an iterator for each one of these types. That doesn't sound too bad. We might do that. A little bit about the implementation using unsafe, index trait. Yeah, I think this is good. Before I forget, let me copy this whole thing. why computer? Why aren't you giving me the text select thing? Oh, it's because they like to hate when people mess with my pointers. All right. And divider. And that looks good. Array list in this article. Sure. So maybe we just do a little heading 2 and we say array list. And that's where we'll go from there. Okay. Compared to a, let's see. So, oh God, words are hard right now. So what are the aspects of an array list we want to talk about? I guess it's the contiguous memory buffer, and then it's the actual operations. Oh, I guess they also call these array buffers, but I don't care about that. What language calls an array list an array buffer? JavaScript. I see. I don't know what array buffer is in JavaScript compared to just array. I guess it's like binary data. It's more low level, maybe. Okay. Okay, so to understand an array list, there are, okay, let's see. There are 2 important parts to understanding and implementing an array list. Only 2, guys. A contiguous memory allocation. We'll just call it allocation. Well, we're probably going to use the word buff in our... We're probably going to use the word buff in our... just type. An array list, contiguous memory buffer. The contiguous memory buffer and dynamism. I'm gonna have to rewrite this. For some reason, I'm having a hard time with words. Okay, there are 2 important parts to understanding implementing the contiguous memory buffer and dynamism. Okay. And dynamic size, sure. I think that is good. We've already handled implementing a growable contiguous memory buffer to base our array list on that we called rawvec, copying the Rust studlib. Okay. So we will make this code, this code, this code. Let me scroll up, down a little bit. And handled implementing should be a link to that article. Should be this one. Like it. So now that we have that buffer, what do we do? What does that provide us? Okay. First thing it provides is a pointer to the first block of data. T size, basically T size block of data. I think that's good. To the first T size block of data. Yeah. I think that's fine. T size block of data. Yep. And the capacity size of that buffer. Okay. So what does this mean? This allows us to use pointer math and Rust to reach every block of data that we use. Okay, too many to reach every block of data in linear, no, not linear, constant time. Constant time. This is why array-based data structures have constant time O of n reads. To get to any pointer in the array, all we have to do is add the offset indexed, the offset, aka index, to the first pointer that we have stored in the raw vec. Okay, so I think this is pretty good. I don't completely hate this. First thing that it provides is a pointer to the first T size block of data and the capacity size of the buffer. The buffer, this allows us to use pointer math and Rust to reach every block of data in constant time. This is why array-based data structures have constant time O and reads. To get to any pointer in the array list, all we have to do is add the offset, aka index, to the first pointer that we have stored in the raw vec. Yeah, I think that's pretty good. So what's the second thing it provides us? The second thing raw vec provides us is growing the memory buffer allocation per our request. Okay. If you want to read more about the cost of resizing and how resizing works, I recommend going back to that post. I think that's fine. I think that's good. I guess I could link to it one more time in case you didn't get the first link. Here's a second one. Okay. Yep, I think that's good. One second. Nope, we're good. Okay, so back to that post. Hopefully this helps explain why we started with rawvec. I think that's cool. Constant time on reads and deletes. No, constant time on reads. I said on reads. Oh my god, constant time. Is anybody paying attention? Did you really let me say constant time on reads? Thanks, Alice. Unbelievable. Unbelievable. Okay. Constant time 01 reads. Okay. To get to any pointer in the array list, all we have to do is add the offset aka index to the first pointer that we have stored in the rawvec. The second thing rawvec provides us is growing the memory buffer allocation per our request. If you want to read more about the cost of resizing and how resizing works, I recommend going back to that post. Hopefully this helps explain why we started with rawvec. So maybe this whole section is actually about rawvec. Rawvec foundation. Okay, sure. Rawvec foundation. And then this is just going to be ArrayList. We've talked about constant time reads. What about add and delete? And Rust and the implementation below. These methods are called push and pop. Okay. And now let's go to the vec docs and just link to push, because it should say pop and push are at the back. What did you do? I swear I just clicked pop. Okay. I kind of hate sometimes how this is alphabetized, but then the docs aren't. And I mean, I get probably why that happens, but it's still annoying. But I guess this isn't even actually alphabetized, is it? Is it? No, it is. But then these aren't. It gets confusing. Because you assume that if you see something in a certain order on the left-hand side, that it would be in that same order over here. But it certainly isn't. Guess that's just how Cargo Doc works. It's probably this is the order of the source code, and then this is alphabetized for you. Guessing that's how that works. Anyway, one sec. Okay. So appends an element to the back of a collection, and pop, of course, removes the last element from a vector and returns it. Okay. So let's just say push. We'll use that as an example. Okay. In Rust in the implementation below, these methods are called push and pop. As you can read in the studlib documentation for vec pop. Is this too nerdy to do this? No, that's good, because that's actually also like valid Rust syntax, right? If I was doing a use. Well, not, yeah, I mean, kind of. I don't know if that would exactly work for non-static methods. But anyway, we'll just pretend that works. As you can read in the studlib documentation for vec pop push, we'll make this code. Studlib documentation is the link. Both of these operations occur at the end of the vec. At the end of the vec. Yeah, I think that's good. In terms of vec_dec, these are pop back and push back. I don't know if that's too confusing to bring up vec_dec here. I might take that list out, that sentence out. Everything's a list apparently now. I mean, a sentence is just a list of characters, right? Terminated by a full stop or period, depending on your preferred flavor of English. In terms of vec_dec, these are pop back and push back. When adding and deleting from the back of an array list, these operations, no, I can make this simpler. Adding and deleting, adding to and deleting from the back of an array list is also O of 1 constant time. Because of resizing, okay, technically on resizing, this isn't true, which is why we say it is amortized constant time. Okay. Is also O1 constant time. Yeah. Let's see. There's probably something I can actually do to explain what this does. We've talked about constant time reads. What about add and delete? in Rust and the implementation below, these methods are called push and pop, as you can read in the stdlib documentation for vec, pop, push. Both of these operations occur at the end of the vec. In terms of vec-deck, these are pop back and push back. I hate this sentence, actually. I think it distracts from the point. According to and deleting, adding to and deleting from the back of an array list is also O1 constant time. Technically, on resizing this isn't true, which is why we say it is amortized constant time. Similar to reads, all that's needed is to get to the next available block in our buffer using buffer/rawvec using pointer math. All that's needed is to get to the next available block in our buffer rawvec using the offset, namely len. That's too confusing. Using the offset. Okay. In our buffer rawvec using Okay. Similar to reads, all that's needed is to get to the next available block in our. Okay, I see. I'm trying to do too much at the same time. To add a new element to an array list, we find the next available block in our buffer rawvec, which is simply say pointer plus len. I guess this could be here. Except I'm not actually going to put a len method, so maybe it makes more sense to say .len. Pointer plus ArrayList.len. I think people are going to know what I mean. I hope. What's up, pizza? How's it going? To add a new element to an array list, we find the next available block in our buffer rawvec, which is simply a pointer plus array. Okay. Plus ArrayList.len. And write our new element at that block. And then we can say this. Adding to the back of an array list is thus O1 constant time. Technically, on resizing, this isn't true, which is why we say it is amortized constant time. Okay. To add a new element to an array list, we find the next available block in our buffer rawvec, which is simply pointer plus ArrayList.len, and write our new element at that block. Adding to the back of an array list is thus O1 constant time. Hey, Infinite, what's up? Technically, on resizing, this isn't true, which is why we say it is amortized constant time. Okay, similarly, I'm not going to say similarly. To delete an element from an array list, we find the last position in our buffer. Building Voron Stealth Burner for my ANET A8, which won't be an ANET A8 anymore soon. Cool. Very cool. I don't know why I read it in that voice. To delete an element from an array list, we find the last position in our buffer. That's not true. We find the last element. We calculate. How about this? We calculate the offset of the last element that has been added, which is simply pointer plus ArrayList.len -1. Okay. People are probably super used to this, unless you're brand new to coding, in which case, I don't know why you'd read this article. To delete an element from an array list, we calculate the offset of the last element that has been added, which is simply pointer plus ArrayList.len -1. Nice. And return the data that is, and return the data in that block. Okay. To delete an element from an array list, we calculate the offset of the last element that has been added, which is simply pointer. Maybe we should just say push and pop. To pop an element from an array list, I think this is better. And return the data in that block. Looks good. This is also, again, we just calculated, we just did a, again, we just dealt with constants. So pop, so deleting, popping from the back is also O1 constant time. Okay. This is good. So what if we wanted to add or delete, add an arbitrary index? We no longer have our constant time guarantees because we have to copy because we have to copy right, because we have to move our data around. was we have to move any data after that index. Because we have to move any data after that index. Maybe we'll just say, yeah, move any data after that index to make sure that our buffer still has valid data at every point. Still has valid data at every point from pointer. Yeah. At every point. I think that's pretty good. Shezron, what's up? Switch testing, we can do that. So what if we wanted to add or delete an arbitrary index? We no longer have our constant time guarantees because we have to move any data after that index to make sure that our array list still has valid data at every point. E.g. mem copy. Isn't that what it's called? Yep. Yeah. So what we've been doing, not EG, it's actually Viz, namely mem copy. I knew it was going to be a big comma. I don't want a big comma. Oh no, it wasn't a big comma. It was the right comma. We have to mem copy any data after that index to make sure that our array list still has valid data at every point. Thus, adding, deleting at an arbitrary index is O of n linear time. Okay. Yeah, so we've been doing this data structures series in Rust, and look up span helpers mem move in C# docs. Nice. Yeah, that'll be that might be interesting. I'll have to try to remember that. Rust DSA ArrayList. Yeah, anyway, we're doing a data structures and algorithms series in Rust. And so we're writing a blog post every week about it, and then we're implementing the actual data structure in 2 different streams. So this is the blog post stream. Next stream will be the data structure stream. So yeah, that's the idea. It's on Substack, so you can also subscribe to it if you want to. You can get emails when I send new posts out. And you don't have to click the link. You just open the email. You know, it's like an actual newsletter if you don't know how Substack works. Okay. Thus adding, deleting at an arbitrary index is O in linear time. Okay. So then this is basically, I guess we'll still just call it ArrayList. Yeah, that's fine. Here is a simple implementation of ArrayList with push pop with push pop. I'm just going to do push pop and an index trait impl for reads. Forget by index. I think that's good. For get, I'll just write it out. Get by index. Okay. To do impl array list. All right, how about it? Let's just mark a couple of these as code things for funsies, and then we can do a switch test. Do I know the difference between mem move and mem copy and when to use them? Oh, that's true. No, you're right. This technically you would want a mem move, not a mem copy, right? In this case. That's true. I mean, in one way, if you did a mem copy, it wouldn't matter. Because as long as your order of operations was fine. But you know, I don't actually know the difference between mem move and mem copy. Like, I mean, I know them theoretically, right? But I mean, if what you mean is it's as simple as one moves the data and one copies the data, then yes, I do know the difference. But if it's deeper than that, then that might be problematic, and maybe I need to read about it. Despite what that one GitHub report said, I'm actually not a C developer. Here is a simple implementation of ArrayList with push pop and an index trait impl for get by index. Okay, we'll just write out implementate. No, we'll just say impl. And an index trait impl. Mem move provides safety and mem copy does not. If you want, I could expand. Sure. Or I can look at it online. I mean, you might as well just summarize it for me. I'm assuming that you're actually correct at me. Assuming that you're correct, you know, we should be good. I'd be happy for you to just expand on it for me. Okay, so we have our summary. Let's finish this summary. Shezron, are you good if I just finish writing this summary and then we do the switch testing? You got a little bit of time. I don't want to put you out by waiting on the switch test. But I just have like a couple more sentences to write here. Okay. This is fine. And I forget what I don't actually know if I know what I'm doing next time. Let's change this. It's hilarious as if Shezron just went away, you know? He's gone. Did I put an underscore in my linked list stuff? I might have. I don't remember. Let's look at how I did it. Runs DSA live on Twitch. I did. Okay, so let's go with underscore. Let's go with underscore. Rust DSA live ArrayList.rs looks good. And obviously we're not going to do this. Next time, I think next time is our, yeah, it's our stack and queue thing. Next time we will implement a stack and queue on top of ArrayList and a linked list to compare the differences. Okay. I'm hoping I can fit all that in one stream. It shouldn't be too hard. Okay. Does memmove make a temporary allocation or is there some trickery in it? Yeah, I don't actually know. I think we'll probably have to read about that in a second. Summary, the source code with tests is available on GitHub. Okay. Yeah, maybe we'll just do it. We'll do it together, F Collector. The ArrayList is an extremely useful data structure. I guess we could talk about that real quick. If we were to do a linear search, on an array list is, unsurprisingly, linear. O of n linear time. It's the same as linked list. But because of cache locality, I believe is the right term, but because of cache locality, most systems maybe I should say I'll just say most systems will let's see, because of cache locality, linear search is typically faster on ArrayList. Okay. It's the same time complexity as linked list, but because of cache locality, linear search is typically faster on ArrayList. Perfect. I think that's worth talking about. Little typo there. Okay, that looks good. Memmove takes care of overlapping memory while memcopy could overwrite it. For example, you pass pointer A as the first param and pointer A+2 as the second. Yeah, you'll overwrite the memory using memcopy while memmove prevents that. Oh, I see. I do actually think that I used memcopy last time I wrote this and not memmove. But maybe I forget. Okay. So this has copy non-overlapping. Interesting. I can't remember what it's called in Rust right now. Mem move. It's been a while. Core pointer copy. Okay. Copy is semantically equivalent to C's mem move. Okay, I actually think I just used pointer copy. Okay, that's good to know. Thanks, Amit. I appreciate it. So then mem move is what I want to say we're doing, basically. Yeah, cool. Next time we will implement a stack and queue on top of ArrayList and linked list to compare the differences. Okay, the ArrayList is an extremely useful data structure with constant time reads, adds, and deletes. With constant time reads, adds, and deletes, the latter two assuming you're operating on the back at the end. We'll say at the end. Okay. Memcopy is faster than memmove. Yeah. Yeah. Okay. Interesting. Yeah, I would say, so if I was like actually implementing this for performance reasons, then I might as well use memcopy because it's pretty obvious that I'm not going to overwrite like data that I care about anyway, right? But I'm not actually doing anything that requires a copy. So that's nice. Since I'm just using realloc at the raw vec for grow. The ArrayList is an extremely useful data structure with constant time reads, adds, and deletes, the latter two assuming you're operating at the end. Yes. It is dynamically resizable, but that resizing comes at a cost. Resizing comes at a cost. Comes at a cost. Yeah, I think that's good enough. I don't think there's a heck of a lot more that matters to say. Comes at a cost. Yeah, I'm happy with this actually. This is fine. And then we're going to do the stack and queue on top of ArrayList and linked list to compare the differences, kind of drive the point home on their differences. And then we just have to implement the actual ArrayList, which we should be able to do on Wednesday. So far, that looks like a good day for me. So this post is done. Thanks for watching YouTube. See you later.